Hello and welcome to Help Your Child with Multiplication and Division with Cubit Education. So this lesson is designed to help you help your children with different styles of multiplication and division. Your children or your teenagers will use these methods throughout their school career, throughout their education, and it's always nice to be able to help them. And not everybody understands the different methods that can be used, and it might also give them a bit more of an insight into, give yourselves and your children more of an insight into the different methods and which one works best for them and which ones work best for yourselves. So we're going to look at the grid method of multiplication, the lattice method of multiplication, and the column method of multiplication. So all three good methods for you to get your head around and for your child to get their head around. We're going to look at long and short division using the bus stop method and using a style called chunking, which it's quite nice if you have like whole number answers, but we'll get to that anyway. Doing 23 times 12. So we're going to look at the grid method first. So I'm going to draw a grid and I'm going to split my 23 and my 12 into tens and units. Now you might have remembered that from school, and obviously if you're using money on a regular basis it should be quite easy for you to do this. So you've got 23, so 20 would go in one column and 3 in the other, and then you've got 12, and 12 is made up of 10 and 2, so 10 in one and 2 in the other. Now all we're going to do is we are going to multiply everything here by everything here, and we're going to do, let's start with this square here, 10 times 20. Now, if you're familiar with multiplying by 10, it's really simple. All we need to do is do 1 times 2, which is 2. And then we're just going to add the zeros from each number. So there's 2 zeros. So 1 times 2 is 2 and 2 zeros. Okay? And then we're going to do 10 times 3. Now, if you're not sure if 3 tens, if you don't know that 3 tens are 30, again, 3 times 1 is 3, and we'll just add 1 0. Here we're going to do 2 times 2, which is 4, and add a 0, 40. And then 2 times 3 is 6. Okay? So now all we're going to do is we're going to add all of those together. So I'm going to do a column method of addition, and I've split this again into hundreds, tens, and units, because as you can see I've now got 200 from here, 30, 40 and 6, and I've split those into their hundreds, tens and units. And we're just going to add down, so the units down here is just going to be 6, and then here we have 4 add 3 is 7, and then 2 on its own. So our final answer is 276. Okay? So just let you take that in for a second. If you'd like to pause the video at any time, rewind any time, take your time, learn each method and understand why you're doing something. And if you have any comments or questions, just comment at the bottom of the video or in the course comments section if you're watching this on Teachable. If you're watching this on YouTube, it's just in the comments. Or you can still email us if you have any further questions or comments at info@cubiteducation.com. Okay, so I'm going to do that same method now, but we're going to look at a harder number. Okay, so we're going to look at 223 times 124. Now in this case, we're going to have to draw another grid, but this time we're going to have 3 columns and 3 rows because we have 3 numbers. So this time I have hundreds in there, so it's 223. So I'd split that up, 220 and 3, like that. And then 120 and 4. Okay, down the side. Just in case you're wondering, doesn't matter if you put 124 there and 223 there, it works exactly the same. Now, we do have more zeros here, so it is a little bit harder. So all we're going to do is, again, multiply everything here by everything here. And let's start with this one. We're going to do 1 times 2, which is 2. And then we have 4 zeros to add this time. So it's 2 and 4 zeros, and that's 20,000. And then we're going to do 1 times 2, which is 2, and add 3 zeros, 2 there and 1 there. And then we've got 3 times 100, or 1 times 3 is 3, and we add 2 zeros. Or if you know that 300s is 300. Okay. All right, nice. So looking at the next row, 2 times 2 is 4, and then we have 2 zeros there and 1 there. So that's 4 and 3 zeros, sorry. And then 2 times 2 is 4, and only 2 zeros this time. And 2 times 3 is 6 and 1 zero. Okay, almost finished. 4 times 2 is 8, and we add 2 zeros. 4 times 2 is 8, and we add 1 zero. And 4 times 3 is 12. So we've now got our grid all finished. We just need to add those up. Now again, this is harder because we've got bigger numbers. So I've done us a column, and I have split it again into hundreds, tens and units, but I've got these extra ones here, and if you're not sure what they are, so we've got our units as normal and our tens as normal, so we have 80, 60 and 12. 10 and 2 makes 12, so 110, 2 units. We have our hundreds, 300, 400, 800, but then we have thousands, so we have 2,000 and 4,000. And then we have our tens of thousands because we have 20,000 here. So 20,000, we needed a tens of thousands column. And all we're going to do is add them up. So looking down our units column, nice and easy, that's just going to be 2. And then if we look down our tens column, we have 8, 6 and 1. So that makes 15. Now, because we have 15, 15 has a 10 in it, a 10 and a 5. So we put our 5 at the bottom there, but we have to carry the 10 over to the other side. And the reason for that is because if you think about the number system, if you go from 1 to 9, 1, 2, 3, 4, 5, 6, 7, 8, 9, then once we get to 10, it changes to 1 whole 1 and 0 units, 1, 10, 0 units. And then if we go 11, 12, 13, 14, 15, 16, 17, 18, 19, as soon as it gets to 20, it goes to 2 tens and 0 units. So we just have to move that 10 along to the next column. And we've just popped it there to show that we're going to add it to this hundreds column here. Now again, 8 plus 4 plus 3 is 15, plus the 1 makes 16. So I'm going to put my 6 there, and again, carry the 1 over to the next column. And then we add this one, 4, 6, and add the 1 is 7. And then finally, we'll just have the 2 on its own. So this is our final answer, okay? And if you're not sure how to read the larger numbers, it's 27,652. But we can also put a comma in, and a comma goes every 3 spaces back. So we start at the end of the number, so we start at the 2, and we're going to go 1, 2, 3, and we put a comma. Now there isn't another 3 digits, so we don't need another comma, but it just splits it out. So you can see that that's 652, and you can see that that's 27. And so that must be 27,652. Okay, so we're working with some bigger numbers, which is really good for the younger children because it challenges them a little bit more. And you can use all of these little tips and things to explain to your child, like the hundreds, tens, units, or the thousands, tens of thousands, and putting the comma in. Make sure they're really aware of number, and it really helps when they get older because it will help with everything. If they have a really good foundation of number and they know their multiplication tables and they can quickly do things like this, it will really help them later on. It will help them with factors, multiples, primes, fractions, percentages, anything like that. Okay, so these are really good skills to have because even if they know the multiplication and they know how to use these methods, practicing them regularly will also help with other subjects, with the topics, sorry. Okay, so let's move on then. We're going to have another look. We're going to have a look now at the lattice method. So we're going to go back to the first question that we looked at, 23 times 12. And this time we're going to do it in a different way. So we're going to have a grid still. And if I remember correctly, this method was introduced by Fibonacci. And if you want to look into him, he has some interesting theories. He came up with the Fibonacci sequence, and I believe he was mentioned in a movie with Tom Hanks, The Da Vinci Code. So you know, it's really quite an interesting mathematician if you want to go away and do a little bit of research. So 23 times 12. Now this time we haven't split it into 20 and 3. We've literally just put 2, 3. So it's easier because you're not dealing with lots of zeros. And then we've put 12 here. Now, the difference with this method as well is we need to put our diagonal lines in. Okay, so we've got diagonal lines going through. Now, if you're drawing this out, try and make this quite square, because then your diagonal lines need to kind of, as best they can, mine's not great, but they need to kind of like link with each other like this. Okay, because you're going to need to add up in these diagonal columns rather than going vertically. Okay, sorry, I'm just having a drink of water, so if you can hear that, I apologise. Okay, so what we're going to do is we're going to multiply across the same way we did before. But you've got to think that this is kind of like your tens bit, and this is going to be your units bit. So 1 times 2 is 2. So I've got 0 tens and 2 units. And 1 times 3 is 3. So 0 tens, 3 units. 2 times 2 is 4, 0, 4. And 2 times 3 is 6. So not only will this help with using multiplication without a calculator, but your children should then be better at their multiplication tables in general because they're practicing them regularly. Okay, so then all we're going to do now is extend these diagonal lines. I like to do this because it creates a nice clean finish and you can see your answer really clearly. And we're going to add up below the diagonal lines. So this line, this one here, there's just 6 underneath that one, so that's 6. And then we add up in this diagonal, 4, add 3 is 7. And then inside there is 2. So our answer is 276. And as you can tell from your previous working out, if you've been taking notes, that's exactly the same answer that we got to the question when we did it before using the other method. Okay, so I really like this one as well. As much as the column method is what I'm used to, this method's nice and clear, I think. It can get a little bit messy if you've got really large numbers, which you'll see in a minute, but it still works nicely. It's just remembering how to do it as well, which sometimes younger children are pretty good at remembering actually, but if you're trying to teach this to a student who's a bit older, say 14, 15, they kind of get a bit fed up and they're, but it's a good one to try. Give it a go. Okay, so let's have a look at the 3-digit question using this method. So again, the same one, 223 times 124. So this is going to need a bigger grid. We need to put our numbers in, and this time obviously we've got our three columns and 3 rows now because we've got 3 digits, and again no zeros. 2, 2, 3, 1, 2, 4. So that's another reason why you might like this method better, because there's not a load of zeros to add up later. But you see how it can get a bit messy now. Sorry, my battery looks a bit low. So we are going to put in our diagonal lines, and we are going to begin to add up. Sorry, not add up, we're going to begin to multiply. So we're going to do 1 times 2, and that's 2. So again, we put 0, 2. 1 times 2 is 2, and 1 times 3 is 3. So don't forget, this is our tens, this is our units. 0, 2, 1 times 2 is 0 tens, 2 units. Okay. Then if we go down to this one, 2 times 2 is 4. Again, 2 times 2 is 4, and 2 times 3 is 6. Then we have 4 times 2 is 8, 4 times 2 is 8, and then on this last one, 4 times 3, so 4 times 3 is 12, and that means we've got 1 10 and 2 units, but it's easy to remember because you just write 12. 1 in there and 2 in there. Nice and easy. Now, again, we extend our lines, and as you can tell, and I did this before but I didn't mention it, I've put the answers in blue because sometimes the students tend to add up these bits, and these are our question, not our answer. So just be careful not to add this 4 in, although it's in that diagonal. Okay, just the blue numbers. So it's always nice as well, if you haven't got a different colour pen, to like draw a darker line around here, because then you'll be able to distinguish between the answer and the question. Now, this one's a bit more complicated, so the 2 here just is as normal. We put the 2 there underneath the diagonal. And then if we add along this diagonal, we have 6 plus 8, which is 14, plus the 1, which makes 15. Okay, now the 15 is a 10 and a 5, so our 5 goes here, but we still have to carry over that 1 into the next column, in the same way we did before. So when we're adding, because we're adding up now, so we can carry it over. So then we add these up along here, so we've got 8 plus 4 is 12, 15, 16. Okay, so I put my 6 there and carry my 1. Okay, 4, 6 and 7. So 4, 5, 6, 7. 7 goes there. And then in this one, don't forget not to add this 4 because that's the question, 2. And then there's nothing here, so we don't need to add anything. And as you can see again, we've got our answer, 27,652. And I've put it with the comma in here just so you can check again. So just be careful when you're writing out your answers to go back every three, 1, 2, 3, and put a comma. And it helps you to read the numbers. Okay. Right, so let's have a look at the column method now. I am only going to do the 2-digit one with the column because, actually no, I will do another one. I'll do a 3-digit one with the column method as well so you can see how it changes. So let's have a look at the 2-digit one first. So we've got our hundreds, tens and units columns, and we need to basically, the same thing happens. We do everything on the top multiplied by everything on the bottom. So we're going to do everything on the top multiplied by 2, and then we're going to do everything on the top multiplied by 1. So let's start with 3 times 2. Okay, 3 times 2 is 6. And then what we're going to do is we're going to do the other number on the top. 2 times 2 is 4. Okay, and so we've done everything on the top multiplied by this number. And now we're going to do everything on the top multiplied by this number. But before I do that, I have to add a 0. And the reason for that is it's because we're moving into the tens column now. Okay, so now what we're going to do is begin exactly the same way. 3 times 1, which is 3, and 2 times 1, which is 2. And now I've finished with everything has been multiplied by everything else. And so I just need to add those two numbers together. I need to add 46 and 230 because those are our answers down here. So I've drawn my column out again, but this time I'm adding them. So 6, 4 add 3 is 7, and then the 2 on its own. So our answer is 276. Okay, so let's have a look at the same column method, but this time using the 3-digit one. Now this is a bit harder, and this is the reason why a lot of people struggle with this. So let's have a look at it anyway, and then you can decide which method you think is best. So what we need to do is we have our hundreds, tens and units columns, but I have added on the thousands and the tens of thousands because we will have to use those. So what we're going to do is we're going to start by multiplying, we're going to multiply everything on the top by everything on the bottom. So first of all, we're going to start by multiplying all of these numbers by this one here, this first one. So we're going to do 3 times 4. 3 times 4 is 12. Now 12 is going to be written as a 2, and then we're going to carry the 1 over to the other side, to the next column. And then we're going to do 2 times 4. So everything is being done by 4. Now 2 times 4 is 8, but we've got to add on that 1, so it actually makes 9. And then finally we're going to do the other 2 times 4, which makes 8. So everything's been done by that 1 unit. And now we're going to do everything by the 10, so by the 2. So add another line, and this time, because we're doing the tens column, we need to add a 0. And then we're going to do 3 times 2. And 3 times 2 is 6. Nice and simple. Okay, and then we're going to do 2 times 2, which is 4. And then finally, 2 times 2, which is 4. Okay, and now finally we're going to do the 1, and that's the hundreds column. So this time we need to add 2 zeros before we start. And then we're going to do 3 times 1, which is 3. And 2 times 1, which is 2. And 2 times 1, which is also 2. And now what we've got to do is, ignoring that 1 that we carried in the red, we've got to add up all of these numbers. Okay, I'm going to put another line, and I'm going to add in rows. So I'm going to do 2 add 0, which is nice and easy, 2. Now if we look at this, we've got 6 add 9. Well, 6 add 9 makes 15, so I need to put my 5 in, and I need to carry my 1 onto my other column, and I've put it underneath this time, just so it's easy to see which ones I've got to add up. So 8 add 4 add 3, well that's 15, plus the 1 here makes 16. So again, 6 and carry the 1. 4 add 2 add 1 is 7, and then 2 on its own here is just 2. So as you can see again, exactly the same answer as before, 27,652. And I've written it here with the comma in as before. Okay, so we've done with the multiplication. It's now time to move on to the division. And the division is quite nice. I've tried to keep it nice and simple, and I hope you get on well with it. So have a go at a few questions. Sorry, I've just given you the answer to the first one there. But have a go at these few questions. Pause the video. Hopefully you didn't see it quickly enough. But have a go anyway. See if you can do them, and then press play for the answers. Okay, so I'm hoping you've paused the video, you've had a go. I'm going to give you the answers. If you're stuck with anything, or you think I've made a mistake, which is completely normal, just want to let you know that it's okay to make mistakes. We learn from them. And if there's any questions, again, just comment below or send us an email at info@cubiteducation.com. Just make sure that you help your child with multiplication and division in the subject section of the email, so that we know which kind of video or course or information you're talking about, and we can answer you quickly. So here are the answers. I'm just going to put them up quickly. So 21 times 45 is 954. 31 times 64 is 1984. 234 times 36 is 11,664. 127 times 332 is 42,164. And 123 times 2,456, our little challenge question there, is 302,088. I hope you got on well. And let's move on to some division then now. So we're going to look at short and long division using the bus stop method first. And this is my favourite method, most accurate I think. And I do it in quite an easy way, so as not to do too much working out going down the page. There might be a certain way that your children are learning where they go down the page, and if that is true and you want me to do a video on that, just let me know and I'll do that. But I just like it this way because it looks clear and it makes sense. Okay. So 234 divided by 6 looks like this in the bus stop. Now, first of all, I'm going to ask myself, can I put 6 inside of 2? Okay, and I can't. Okay, 2 doesn't divide by 6. Well, it would, but you'd get a decimal answer and you don't want that. So instead, I'm going to put 6's into 23. Okay, so let's look at the 6 times table. And if we can see, up to 24, we have 6, 12, and 18. We can't go to 24 because we've only got 23. So that leaves us with 3 6's, which I'm going to put at the top there. And then from 18 up to 23 is 5. So there's 5 remainder. So I'll put my 5 here to make 54. So if I write out the rest of the 6 times table up until I get to 54, as you can see, I've got 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so I've just gone up in the 6 times tables until I get to 54, and there are 9 numbers there. So that's the answer, 9. So it's 39. 234 divided by 6 is 39. Okay, nice and easy that one. Let's have a look at this one. 958 divided by 2. Now again, you could do that really easily by halving it, but just to show you an easy one, I wanted to put it into the bus stop. So first of all, 2's into 9. Well, we can do that. I'm going to look at my 2 times table a little bit, just in case. If you get stuck, write down your times table. 2, 4, 6, 8, 10. I can only go up to 8. So that's 1, 2, 3, 4. So I can fit 4 2s into 9. But from 8, the difference between 8 and 9 is 1. So I've got 1 remainder. Okay. So then I'm going to put how many 2's go into 15. Well, again, looking at my 2 times table, what's the closest number to 15? And it's 14. 1, 2, 3, 4, 5, 6, 7. So 7 goes there. And from 14, which is the closest one I can get, up to 15, there is 1 remainder, 1 left over. And now I want to know how many 2's I can put into 18. And I've already got my times table up to 18 here. 1, 2, 3, 4, 5, 6, 7, 8, 9. So there you go, finished. You've got nothing left to do. You've found them all, and the answer is 479. Okay, so just be careful when finding the differences. So when I said how many 2's go into 9, I did 2, 4, 6, 8. Well, I can't go any further because the next number is 10, not 9. So I can only fit 4 in, and then it's what difference it is from 8 up to this number here, 9. And from 8 to 9, it's only 1, and that is our remainder. Okay? Okay, so let's have a look at one now with a remainder. So we're going to have a look at 378 divided by 4. And first of all, let's look. We can't put 4 inside 3 because 3 is smaller than 4. So instead we're going to do 37. So let's look at the 4 times table. And as you can see, the closest number to 37 is 36. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9. I can fit 9 4's into 37. Now the difference, remember, is your remainder. So the difference between 36 and 37 is 1. So I'm going to put my remainder 1 just there. Looking at my times table again, the closest I can get to 18 is 16, and that's 1, 2, 3, 4. So I'm going to put 4 there, but there are from 16 up to 18, there's 2 left. Now I've got a 2 remainder, but I've got no numbers left. And what I do here is, because I've got no numbers left, it means it's going to be a decimal. So because I've got no numbers left here, that tells me I need to put my decimal in, and I need to add a 0. Okay, and that makes 20. So now 20 goes exactly into the 4 times table. 1, 2, 3, 4, 5 times. So it's 94.5. Okay, so that's our answer. Now then, a harder one still. And I think with more remainders, yes, definitely. Okay, so let's have a look at that then. 5,689 divided by 11. 11 is an easy times table. It looks like this. 11, 22, 33, 44, 55, and so on. Okay, even past 100, even past 99, it's an easy times table to figure out, and I'll probably do a video on it because it is actually really interesting, and it helps to understand how to multiply by 11 and 12 as well. 12 is an easy number to multiply by, but that's for a different time. So we have how many 11's go into 5? Well, we can't put 11 into 5 because 5 is too small. So we're going to put 11 into 56 instead. And as you can see, the closest I can get to 56 is 55. And that is 1, 2, 3, 4, 5 times. So 5 goes there. Now the difference between 55 and 56 is 1. So there's 1 remainder. Okay. And then I'm going to think, how many 11's can I put into 18? Well, that's only 1. And so I need to put that there. Now the difference between 11 and 18, yeah, because we can only fit 1 in, okay, is 7. So from 11 up to 18 is 7. So we've now got a remainder of, a number of 79. And the closest we can get to 79 is 77. So it really helps to have this here because you're not having to think too much. So it's 1, 2, 3, 4, 5, 6, 7 times. So 7 goes there. Now the difference between 77 and 79 is 2, leaving us with a 2 remainder. Now as I said before, if it's a remainder and there's no other digits, we need to add our decimal point and put a 0. Okay, now I've got to think, how many 11s can I put into 20? Well, the closest I can get to 20 is 11, so that's just 1. So 1 is going to go there, and the difference between 11 and 20 is 9. Okay, and I just add another 0. And we do that again. How many 11s go into 90? The closest I can get to 90 is 88. And as you can see by now, we know that that's 8 times. Okay, so 8 times is going to go there. Now the difference between 88 and 90 is 2, so that's going to be our remainder, and we put a 0. Now, I don't know if you've noticed yet, but if you can see 20, 90, 20, you might notice there might be a pattern starting to form here. How many 11s go into 20, and that's 1, with a remainder of 9? And so we add another 0, and it's going to be 8 again. So that pattern is going to carry on and carry on and carry on. So our answer is actually going to be 517.181818181818, and it's not going to stop. So what we do, to show that that recurs on and on, we put a dot above the numbers that recur, which is 1 and 8. So that's our final answer. And, you know, being able to do this is really, really useful for yourselves and your students, because it just increases your knowledge of maths, knowledge of number, and the more and more you practice, you know, you can train your mind to be better with numbers. There's so much research about, you know, changing the way your brain connects with itself, in terms of cells and pathways, which increases your intelligence or changes your mindset. It's like learning to be positive by, you know, training yourself to think positive. Eventually, everything becomes positive, and you know, it's all about mindfulness. So you can train your brain to be better with numbers and better with maths. Okay, one more then with this method. 6,985 divided by 12, and I've written out the 12 times table down there because it will help me out. And I need to see how many 12s go into 6. Well, we know we can't do that. So 12s into 69. If we go, the closest I can get to 69 is 60. And that is 1, 2, 3, 4, 5 times. So 5 goes up there. And the difference between 60 and 69 is 9. So that's our remainder. And now we need to see how many 12s go into 98. So the closest I can get to 98 is 96. So that's 1, 2, 3, 4, 5, 6, 7, 8 times. And I put 8 there. And then the difference between 96 and 98 is 2. So we now have 25. How many 12s go into 25? Well, the closest is 24. So 1, 2. 2 there. And the remainder, the difference between 24 and 25 is 1. Now, like I said before, we've run out of numbers, so the same applies. We add our decimal point and we add our 0. Now then, this is the tricky part. We can't put 12 into 10. Okay, and because of that, we have to say that we can't do it. It's a 0. And then we just add another 0. So now we can see how many 12s go into 100. So let me explain that again. We can't put 12 into 10, so we have to put a 0 there. We can't just leave it because it will give a wrong answer. Can't add the 0 here and put nothing here. It's like adding the decimal point or adding the 0 without adding the decimal point when we run out of numbers. You can't do that. So we can't fit 12 into 10, so we put the 0. And once we put that 0, we can then add another 0 on, and that becomes 100. How many 12s into 100? Well, as you can see, the closest I can get to 100 is 96. And that's 1, 2, 3, 4, 5, 6, 7, 8 times. Pop 8 there. And the difference between 96 and 100 is 4. So it's going to be 4 remainder. And I'm going to add a 0 again. And I'm going to say how many 12s can I fit into 40. So it's a bit repetitive, I get that. But once you get really good at it, it's quite quick. So don't worry. Just practice makes perfect. And the closest I can get to 40 is 36. Okay, that's 1, 2, 3. So 3 times. And as you can see, the remainder from 36 up to 40 is 4. Add a 0. We already know how many 12s are in 40. We've just done it. That's 3. Remainder 4. Add a 0. remainder 3. So, sorry, 3. So we can see that that 40 now is going to carry on and that 3 is going to carry on. So we would write our answer as 582.0833 or 083, and we'd just put a dot above it because we don't want to write out loads and loads of 3's. Okay, so we've got 582.083. I could have left it as 13 and put the dot above there if I wanted, but I just put 2 and put the dot above there. So that 3 is going to go on and on and on and on. Okay, lovely. So I hope that's helped. I hope you've understood the long and short division using the bus stop method. We have one more method to get through, and that is the chunking method. But before you have a go at that, have a go at a few questions. Pause the video and see how you get on. Okay, I'm assuming you've paused the video and had a go. So here are the answers. And I hope you did well on those. If you have any questions, again, please don't hesitate to comment or email us at info@cubeteducation.com. And again, don't forget to put the subject line, help your child with multiplication and division. Okay, let's look at chunking. Last one. Okay, so chunking is great if they are whole number answers. Sometimes when there is remainders, it gets a little bit tricky because it's hard to wonder how to write it, hard to think about how to write it down. But I'll show you this method and then you'll probably understand it a bit better. So with chunking, what you do is you try and think of a number that goes into the 6 times table here. So this is the number we're dividing by. So try and think of a big number that goes into the 6 times table. So for example, I could do 10 times 6 and that's 60. Okay, so it's quite a big number. So if I did 10 times 6, which is 60, because if you don't know, when we times by 10, we just add a 0 on. So 10 times 6 is 60, so we just put a 0 on there. Okay, now I'm going to take that away from 156. 156 take away 60 is 96. Okay, so now I do that again. I think, right, what number in the 6 times table goes into 96? Well, I could do 60 again because 60 goes into 96 again. So 10 times 6 is 60. So I take away 60 and that leaves me with 36. Okay, so this method isn't fantastic if you aren't very good at adding up or taking away. But, you know, bear with it. You might be really good at that. So we have 36 left. Now, 36, how many 6's go into 36? Does it go exactly? Doesn't it? Now, if you know your times tables and if your children know their times tables, which I'm hoping they do, or they're practicing or learning them now, they should know that 6 times 6 is 36. So I can take that away and it leaves me with 0. Now, because it leaves me with 0, that means I've divided it. I've done it all. So I've got 10 here, and 6 here. So that means that's 10, 20, and 6. So 156 divided by 6 is 26. 10, 26. Okay? Again, it's not my favourite method, but if you enjoy it, use it. Let's look at another example just to kind of reiterate what I've just been saying. So we're going to do 72 divided by 3. Now, it's always good to start with tens. So I'm going to do 3 times 10, or 10 times 3. Okay, 10 times 3 is 30. So I'm going to do 72, take away 30. And that leaves me with 42. So I know now that 30 will also go into 42. So I can do that again. 10 times 3 is 30. Take away 30 leaves me with 12. Now, the reason I'm doing times by 3, remember, is because it's a 3 here. So now I've got to think how many 3's go into 12. And again, if you know your times tables or your children do, they should know that 4 times 3 is 12. So I take away 12, and that leaves me with 0. So how many 3's have I actually used? I've used 10, 20, 4. 72 divided by 3 is 24. Okay. One last one without any remainders, and that's 114 divided by 6. And what we're going to do is we're going to think again, what can I times by 6 to give me quite a big number? So 10 times 6 again is 60. So these 10s are really good until you get as low as you can. So 114 take away 60 leaves me with 54. Now I can't put 60 into that again. So what else can I times by 3? By 6. So I'm going to do 6 times 6 because I know that 6 times 6 is 36, don't I? So I'm going to take away 36, leaving us with 18. Now, how many 6s go into 18? You should know, or your children should know, that 3 times 6 is 18. So I'm going to take away 18 and it leaves me with 0. And then all I need to do is count up this side here, 10, 16, 19. So 114 divided by 6 is 19. Okay, right, let's have a look at 364 divided by 18. This one is going to leave us with some remainders. So I'm thinking about the 18 times table here. What can I times by 18 that will get me really high? So again, I'm just going to do tens because tens are really easy to get your number really small so you can see the times table better. So 10 times 18 is 180. So I'm going to take away 180 from 364. And that leaves me with 184. So I know I can do that again. I can do 10 times 18, which gives me 180. And I take that away. So 184, take away 180 is 4. Now, I have got to do 4 divided by 18. I've got to think, how many 18s go into 4? Well, I can't do that. So before we go any further, let's look at what we've done so far. We've used 20 of them. So far, our answer is 20, remainder 4. Okay. But I'm not going to leave that there. I'm going to find out what the decimal is. So because I've got that remainder 4, but I've got no other numbers to use, just like with the long division method, the bus stop method, I need to put a decimal point. Okay. And I need to add a 0. So I've added my decimal point here, and I've added my 0 here. And now I need to think how many 18s go into 40. Well, 2 times 18, okay, is 36. So I'm going to take away 36. I'm also going to put my 2 in. So I've used this 2 here. I'm going to put it there. Okay. And 40 take away 36, again, leaves me with 4. So I'm going to add another 0. And I'm going to do 2 times 18 again, which is 36. I'm going to take away 36, leaving me with 4 remainder. But I've used 2 more, so I'll put my 2 here. And as you can see, this pattern is going to carry on and carry on and carry on. So our actual answer is 20.22, or 2, with a recurring dot above the 2 to show that that 2 goes on and on and on. We could also say it's 20 remainder 4, like we were going to when we first got the remainder. Depending on the age of your child and depending on how good they are at division, it might be hard for them to grasp the recurring decimal or the remainders. So if you do just want to write 20 remainder 4 and that is valid for their age range at school, then that's fine. Okay. So well done for completing that. That was quite a long session. I hope you did well. I hope you enjoyed the course. And if you have any questions at all, don't hesitate to contact us. And thank you so much for using Qubit Education. And I hope to see you again soon.